talk about electric circuits, the quantity obtainable from electric circuits. And at the end of the class, you are advised to lay hands on exercises on electric circuits, right from your textbooks and the past questions we may have. Before we proceed today, may I know if you have one or two questions posing problem to you on electric circuits, or any other question you may have in other branches. So if you have any, let's have it and see how far we can go about it. Question on electricity or any other aspect you may have. You know what you have done after Monday class on electricity. Do you have anything to show? You have proof yourself. All right. Yes, I raised up your hand. So what do you want me to now believe about you? That you don't have problem, or you have not started working anything, or you don't even understand everything done? Which position now? I will define waves as periodic disturbance that involve transfer of energy from one point to another in space or medium without causing permanent displacement in the medium. Disturbance that involve transfer of energy from one point to another in space or medium without causing permanent displacement in the medium. If you break the definition down, you notice that to produce wave, there must be disturbance, and that disturbance will now lead to generation of waves. Disturbance is when you say you disturb to and fro. Regular disturbance will bring about to and fro movement of an object. So when you are disturbing the particles in the medium, the particles in the medium is vibrating, wave will be generated. This was the definition I gave to you 2 weeks ago. It wasn't last week. So, and from definition we said we classify waves into two. We have two categories, which are mechanical waves, and the second one is electromagnetic waves. We categorize from definition. We have mechanical waves, electromagnetic waves. This is not new thing. You always pretend by bending down writing what you will not read. Mechanical. These are set of waves that require material medium. They require material medium for their propagation. That means to move, to propagate wave from one point to another, there must be material medium along which the waves will go. That means these are set of waves that require material medium. Wave, you can say wave that require material media. They need media for their propagation. Such waves are called mechanical waves. So we give an example of mechanical wave and the medium, material medium needed. You can say example now. Examples of waves. Mechanical waves, of course, can quickly tabulate like this. We have mechanical waves. Number one, you have water ripple. Water ripple or water wave. We have their medium needed. We have water there will be no water ripples or water waves when there is no water. In other words, the water ripple travels along water. Water is the medium required. Number 2, you need rope waves. That require rope for propagation. That's the required medium. Then you also need sound to mention few. Sound requires air as the medium for the propagation. You can also talk about string wave, sound waves. For string, it needs string, and so on. Well, the other type, which is electromagnetic waves, they are set of waves that are produced by the vibration of electric field and magnetic field. There are two, I said it earlier. For wave to be generated, there must be vibration. That's why we say periodic disturbance. Then, and we said electromagnetic does not require material medium. Then, what causes the vibration? The two compound names, electric field and magnetic field, are the one generating electromagnetic waves. And that's why the wave gets its name from the combination of the two fields. Magnetic field, electric field produces electromagnetic waves. And this set of waves do not need material medium for their propagation. So what they need is they travel through vacuum. So we can say that electromagnetic wave examples. These you can have these are waves that do not require material medium. They don't need material medium for their propagation. They don't need their material medium for their propagation. Now, examples of this, please take note of this. Examples of electromagnetic waves are electromagnetic waves are, number 1, you have radio waves. Under radio wave, we still have micro, which is smaller, but let me put it all together by saying radio waves. Then, after this, you have infrared radiation. Infrared radiation. Next to infrared radiation, you have visible light. Next to visible light, you have ultraviolet radiation. Ultraviolet radiation. Next to ultraviolet radiation, you have X-ray, and of course, you have gamma rays. These are examples of electromagnetic waves. As they are arranged in descending order of their wavelength. As it is, we have this one in descending order. Descending order of their wavelength. They are arranged in descending order of their wavelength. That simply means radio has the longest wavelength and gamma has the shortest wavelength. You can come across it in any exam. Maybe 4 of them is given to you the option. Which of the following electromagnetic waves or radiation has the longest wavelength? If you pick any 4. So what you should do from now is to learn the arrangement, and that will now help you to be able to pick. If they give 4, you will know which one has the longest among the 4. Or they may arrange them, maybe 4 in an option, and in descending order, and say which of these arrangements is in the descending order. There are different ways the question can come under this, but what is important is for you to know the order of their wavelength. According to the wavelength, as said, radio has the longest wavelength, while the gamma has the shortest wavelength. But the arrangement is in ascending order of their frequency. It is in ascending order of their, we said descending of their wavelength, but we can say it's in ascending order of their frequencies. So that means the gamma has the highest frequency and radio wave has the lowest frequency. The gamma has the highest frequency, radio has the lowest frequency. But the good news is that both of them travel at the same rate. All electromagnetic wave travels at the same rate. In other words, all members of this have the same speed. You can say electromagnetic wave travel at the same rate. They travel at the same rate, and the speed at which they travel is called the speed at which they travel is called speed of light, usually represented by C, and equals to 3.0 times 10 raised to the power 8 meters. You need not to cram that speed. You always be given where necessary. That's what we call speed of light. And mathematically, it can be expressed. So we can say mathematically, speed of light can be expressed. Speed of light can be expressed as equals F lambda, where C equals speed of light, then F equals frequency, then wavelength. There are 3 parameters here. Be sure that 2 out of 3 will be given, and the third one is what the examiner will ask you to determine. Then, just as we have expression for the speed of light under electromagnetic wave, we can also express the speed of mechanical wave. You can say similarly, the speed of mechanical wave can be expressed addressed as V though it is smaller than that of mechanical waves. If you see in any exam, somebody asks you, what is the speed of radio wave? Can somebody tell us the speed of radio wave in the class? What is the speed of radio wave? Yes.
3 times 10 raised by 8 meters per second.
Clap for him. So what do you think the speed of gamma ray will be? You? So all members have 3.0 times 10 raised by 8 meters per second. Please take note of that. Nevertheless, I've given you the mechanical wave, the speed of mechanical wave. You can say where this is equal to speed of wave. That's mechanical wave now. F still retain its usual meaning. That's the frequency. And of course, lambda stands for wavelength of the wave. So the unit remain the same. Now let's quickly look at types of waves. Types of waves. About 1, mechanical waves. 2, we have electromagnetic waves. 3, we have transverse waves. 4, we have longitudinal waves. Longitudinal waves. Then we have stationary waves. Then we have progressive waves. Then number 5, we have standing wave. Then 6, we have progressive waves. Yes. In fact, you can distinguish the first and the second, third and the fourth, and fifth and the sixth. So I will just explain each of them by distinguishing them. The first two, we'll talk about it. Mechanical waves are waves that require material medium for their propagation. Electromagnetic waves do not require material medium for their propagation. In fact, you can give the examples. Example of mechanical waves, I've listed the example for you. You can add 1 or 2 examples of mechanical wave. Then, electromagnetic wave here, you can also add 2 or more examples of that. But in the tabular form, when you are trying to distinguish mechanical wave in one column, electromagnetic wave in the other column, and you give the definition of the first one, okay, mechanical waves are set of waves that require material medium for their propagation. Example of mechanical wave is water ripples or water wave. Electromagnetic waves are set of waves that do not require material medium for their propagation. Examples, radio wave. Of course, last week, and I said it earlier, when we say definition of wave, periodic disturbance that involve transfer of energy from one point to another in space. If you stop there, you are giving definition of electromagnetic wave. But when you say in medium, without causing permanent displacement in the medium, then you are defining mechanical wave. But a layman or simple, well, can say mechanical require material medium for propagation and electromagnetic. It's still part of what you can use to distinguish the mechanical from electromagnetic wave. You made your point with that 2 points you have given. That means examples of mechanical waves and simple definition you give, the same for electromagnetic wave. You can read more about the 2 of them from your textbook, but that information is enough for you, and you know the examples of the 2. The next 2,
essential physics. There are such types of waves. This 4 was under types of mechanical waves. They not term it as type of waves, but they term it as type of mechanical waves. This transverse, continuous, stationary, and progressive was under types of mechanical waves.
Good. Now, can you hear what he's saying?
Yes, sir.
Good. When we say mechanical wave, it's a type that has some order. Yes, of course, the type of wave are interwoven. And when we say type of wave, and you said it is still under mechanical type of mechanical wave, you are still talking physics. It has not contradicted what is on board. Mention types of waves. The only thing you can now say is that if I mention mechanical wave, can I still mention the other wave when they say which of these? But mechanical wave and some other type of mechanical wave under it's this type of waves. Is that clear to you? And let me say, I've said it before, no textbook is perfect. That's why you are driving off for economical situation, the economy, somebody wants to write WAEC, you have at least 2 different textbooks, because some textbook may make some error in presentation of a topic. You read it in another textbook. Then that's the essence of library too. Is that taken?
Yes,
So I don't want to go into condemning any textbook or whatever, but I can only tell you that you cannot say textbook is perfect, or you cannot say textbook is this. You have knowledge, you pick knowledge, and once you are told that this is right, even if it is not the same way you have in your text, you take note of what is said, it is right. Is that okay? There are some definitions that WAEC will not accept in some of the textbooks we are holding. That's why at times we use marking guide, and that's the essence of coordination. Once we discover that, okay, this one is not in most of the textbooks our students are carrying, not only you. New school physics is being used here and some other textbooks. In Kano or in the East, they use the same textbook. Say mention 3 types of waves or 3 types of waves. They won't say whether mechanical or whatever. Is that taken? All of these are mechanical because they have material medium, and that's the general definition for mechanical. Any wave that have material medium for their propagation, such wave is called mechanical wave. You are right, because you cannot talk about longitudinal without talking about medium, vibration of medium, which is the air. The particle of the air vibrate when you are talking about longitudinal waves. And transverse wave too. Some are mechanical, some are electromagnetic. In fact, all electromagnetic waves are transverse waves. You have examples of mechanical waves that are transverse, and we have all electromagnetic waves are transverse waves. Are you lost? Do you understand what I've just said? So, type of wave, I give you 6. And I'm trying to distinguish the 2 of them. Just follow it like that. And I gave 2 points, two points in each case. You can also pick more, but don't bother yourself more than 3. So, number 2, we are 3 and 4, transverse and longitudinal. Can somebody define transverse wave? What do you think transverse wave is? So that I will not do the talk alone. You should have the idea. That's what we refer to as previous knowledge. Something about wave. You must have done it in SS2. How many of you are hearing transverse wave for the first time? Then I say, what do you understand by it? You are looking at me. What do you understand by longitudinal wave? Longitudinal waves.
Waves that move in a straight path. They vibrate on a straight line.
Okay, that's why we call it longitudinal wave. They vibrate on a straight line, on a long straight line. That's why it's a longitudinal wave. Longitudinal waves, I said if you want to distinguish, tabulate like this, you can refer to this as transverse waves and longitudinal waves. Transverse waves and longitudinal waves. The transverse wave waves are waves whose direction of propagation is perpendicular to the vibration of the particle on the vibration of the particles on the medium. So what are we trying to say? Vibration is this, direction of propagation is this. The wave travel this way. This is vibration. Vibration of particle. Vibration then, direction of propagation of the waves. Or you can simply say direction of the waves. The direction the wave travels is perpendicular to the vibration of the particle that produces it. When vibration is perpendicular to the direction of the wave, propagation of the wave, such wave is said to be transverse wave. And we have so many examples. Like I said earlier, all electromagnetic waves are transverse waves. They are good examples of transverse wave. All electromagnetic waves, they are good examples of transverse wave. That means transverse is 2 in 1. You can cite examples of electromagnetic wave. They are all transverse waves. Mechanical waves, water wave is also transverse. Rope wave is transverse wave. String wave is transverse. So why are they transverse wave? Because their direction of propagation is perpendicular to the vibration of particle on the medium. That is vibration of their particle. Direction of propagation of wave is perpendicular to the vibration of the particle of the medium. So it is transverse. So it means in electromagnetic wave, electric field and magnetic field are vibrating through all directions, and wave also travel through all directions. That is electromagnetic waves. So a good example, as I've given, you can say examples of transverse wave, e.g. electromagnetic wave, can have it, electromagnetic wave. 2, water ripples, string waves, rope wave, they are both transverse waves. Now, longitudinal waves. The longitudinal waves are waves whose direction of propagation is parallel to the vibration of particle on the medium. The vibration is parallel to the vibration. In this case, we can say longitudinal waves are waves whose direction of propagation is parallel to the vibration particle that produce the vibration of the particle that produce the wave. So what we are saying in essence is vibration is this. This is vibration. Direction is also parallel. This is direction of propagation. You have both of them are parallel, but this one is perpendicular. A good examples of this one, wave is sound. Wave. It's only sound wave that is longitudinal. That is longitudinal waves. It's only sound wave that is longitudinal waves. So please take note of that. You have more information you can give, but with these two, you are good to go. Do you know transverse wave can be plane polarized? Transverse wave can be plane polarized, but longitudinal wave cannot be plane polarized. You can have more other points, but you may not bother yourself more than 3 points under this wave. The last two, stationary and progressive wave. Stationary, other name for stationary is standing wave and progressive wave. From the word standing, you know what it means. When the wave is standing, does not move, we call it standing wave. Then progressive, it means that one is not standing. Don't say that. But you can have that idea that, okay, if they say standing wave, it means the wave is standing. And if they say progressive, it means it's not standing. That should be something that will be in your mind if you check your dictionary. But how do we define this? It's so simple. You can also tabulate it the way you did to the above types. Standing, it occurs when two identical waves traveling in opposite direction superimpose. That's why we say standing wave occur. What does it mean for a wave to be identical? We said for a standing wave to take place, there must be two identical waves and they must travel in the opposite direction. The standing wave occurs when two identical waves traveling in the same, traveling in opposite direction superimposed. That's when we say standing wave occur. But I ask, what does it mean to have identical waves? Note, I made mention of 3 important things for standing wave to occur. 1, 2 identical, underline, identical. 2 identical traveling in opposite, underline opposite direction. Then the last one, superimpose. What is the meaning of superimpose? A layman will call it overlaps. Superimpose simply means to overlap. I'm sure overlap is simpler than saying superimpose to you. When we say something overlaps, everybody here know what that means. Do you know it?
Yes, sir.
I hope next class will not say, I do not understand. I understand a bit. You are not asking question now. To define standing waves, you must have 2 identical waves. And those 2 identical waves must travel in opposite direction. And when they now overlaps, the term we use is superimpose. But superimpose simply means when they overlaps, then standing wave will occur. I will use diagram to show you what it means. But the 3 conditions is that it must be identical. They must travel in opposite direction. They must superimpose for standing wave to occur or stationary wave to occur. And my question is, what is identical, or what makes 2 waves to be identical? Before you can say, okay, they travel in opposite direction. What does it mean to be identical?
For two waves to be identical, they must have the same frequency, amplitude, and wavelength.
The same frequency,
Amplitude and wavelength.
yes.
For a wave to be identical, they must come from the same source, having the same frequency and wavelength.
Before, clap for the two of them. Some of you cannot even clap. The first speaker is nearer to it, but it's not properly put. Amplitude, and that means same amplitude, same frequency, they are identical. Or same amplitude, same frequency. You can substitute frequency and wavelength. Frequency and wavelength can be substituted for, but amplitude is different from the two of them. If a wave have the same amplitude, very important, and they have the same frequency, you are free, you are justified, you are correct to say, okay, they are identical. Or the same amplitude and the same wavelength. Either the same amplitude, the same frequency, or the same amplitude, the same wavelength. They are identical. So how do we now put this stationary wave? You can say stationary. You have to calculate like this. You have so this occurs when two identical waves, open bracket, two waves are identical when they have same amplitude and same frequency, or wavelength. Same amplitude, same frequency, or same wavelength. That said, that's when we say stationary waves occurs. When the two identical waves, same amplitude and this, travel, I put this one in bracket, when they travel in opposite direction and superimposed. When they travels in opposite direction and superimposed. When they travels in opposite direction and superimposed, that's when we have standing wave or stationary wave. And I said superimpose simply means overlap. When they overlap, superimposed. So then you can open bracket in front of superimposed and write overlaps. When they overlaps, then that occurs. So we can draw the diagram of the two stationary waves or standing waves. Go on like this. So you have standing waves like this. This of course is Y, and this one can give us X, T axis. This is a good diagram for the standing waves. So you can fix this from here to here will now serve as our wavelength, and this is the amplitude from here to here. That's maximum Y is called amplitude. This is also amplitude below, and so on. That is standing wave or stationary waves. Then let's quickly now look at progressive waves. Progressive waves. Progressive waves also occur this time around when two identical waves travels in the same direction. You know, it's very similar to standing wave, but what is different now is the stationary travel in opposite direction, progressive travel in the same direction. When the two identical waves travels in the same direction, superimpose. When two identical waves traveling in the same direction, superimpose, then progressive waves occur. Progressive waves occur. You can say this occurs when two identical waves traveling in the same direction, superimpose. When they travel in the same direction and they superimpose, then you have, now you have this. Let this be wave A, and you have another one. And that's another wave B. Now, because they have this, we now have their resultant bigger than the two of them. Their resultant, the combination of this, will be bigger than the two. This is the resultant of the two when the two of them combine together. So when progressive waves take place, you have intervariance where superimpose take place. We have constructive intervariance and we have destructive intervariance. Constructive intervariance occurs when trough of one wave overlap with trough of another wave. Then you have constructive intervariance. Trough of a wave overlap with trough of another wave. Then you have constructive intervariance. But when the trough overlap with crest of another wave, trough of a wave overlaps with crest of another wave, then destructive intervariance will take place. Am I communicating?
Yes.
There are two possible intervariance that may occur when you are talking of progressive waves. There are two possible intervariance that may occur. One is constructive intervariance, the other one is destructive. When do we have constructive? When crest of a wave superimpose with crest of another wave, then constructive interference will take place. Am I communicating? Do you understand now?
Yes.
I will ask some things exercise you do on what you are taught today next class. Don't tell me that I was not in the class. I think next Monday will even be the time you write your exam. Is next week our last week? So, crest, or trough, constructive. But once you have opposite, then we have destructive intervariance, which usually take place when a progressive wave is taking place. Am I communicating?
Yes.
When I ask you what do you understand by identical wave, you will not say, I know it a bit. I did not know. Once you understand something in the class, go back home and digest it and look for exercise under the topic to see what and what you can do about it. Diagram can be taken as additional information to the other two. So we quickly talk about properties of waves. We talk about type of wave and we distinguish the two of them. The next thing is property of wave. Then after property of wave, we look at equation of wave, which of course time may not permit us to do that today. But next week we are going to continue with equation of wave before we go on to light waves. Your practicals, the last practical you will do will be on light waves. We rush so that we can have something as the theory before the practical aspect is given to you. Properties of waves. Properties of waves. I'm not saying property of mechanical wave or electromagnetic wave. Wave generally, be it mechanical or electro or any other type. What are the properties of waves? We want to quickly look at property. Yes. How many properties of wave do you know? Okay, 4. Can you mention them?
Reflection.
Okay, reflection,
Diffraction.
diffraction,
Refraction. Refraction.
refraction.
And interference.
Please clap for her. There are 4 general properties of wave. There are 4 general properties of wave. There are 4 properties that anything called waves possess. Anything that is called waves possess it. They are general property. That means we say this is property of wave. Any wave, we have that property. There are 4 of them. And she mentioned those 4 that wave possess. But we have another property. That one is not general. Specific. Some waves possess that property. Not all waves. So I will list the general and I will list the other one and tell you the wave that possess that too. Then we look at them one by one. There are 4 general. 4 general properties of waves. There are 4 general properties of wave. They are 1. Reflection. So that simply means all waves can be reflected. That's what it means. Anything called waves. Number 2, we have refraction. It also means all waves can be refracted. Number 3, we have D, diffraction. All waves can be diffracted. Please take note. We usually experience candidates when we are marking the light strips. DI. Most candidates will put DE. DE is wrong. Of course, we don't mark English, but when what you misspell means another thing, we won't mark that right for you. So if we don't mark English in physics, but if you have DE instead of DI, DEFF has meaning in dictionary, which is not the same meaning with what we want. Take note of that. It is not DE, it is DI, diffraction of light. Now, the last one, that's number 4, where you can say that the fourth one is intervariance. So you can say intervariance occurs in all waves. Anything called wave possesses this property. Although there's another property called polarization. Polarization is a property of waves, but not all waves possess it. It's only transverse wave alone. It's only transverse waves alone that possess polarization as its own additional properties. In addition to these 4, it also have polarization as additional property. Do you understand me?
Yes.
Any example of transverse wave possess polarization. So that means longitudinal wave cannot be, it does not possess that property. That's a sound wave, do not possess polarization, but it possesses all other 4 general waves. In case you come across it in any exam that you will face, and they just say mention 3 properties of wave, please don't mention polarization as properties of wave, because it is not all wave that possess it. It will not be part of the answer. You can only give 3 of the following. Am I communicating? So take note of that. Now let's look at each of the property briefly, what it means. Then we see how far we can go with terms. We have some terms in waves. Before the equation of wave, terms in wave will lead us to equation of waves. Now, reflection. What do you understand by reflection of waves?
Reflection can be defined as the bounce back of the wave. Reflection can be defined as the bounce back of the wave as it hits an obstacle along the path of propagation.
Okay, that's an idea. Any other submission? He got it, but we don't use bounce back. We don't use the word bounce back. Yes?
Is the ability of the propagated wave to be thrown back from the obstacle.
Ability of a
Propagated wave
to
be thrown back
be thrown back. You are still talking pieces. Anyway, clap for the 2 speakers. We all know ball, Abi. When you throw ball away from you, you are the thrower. You throw the ball will be traveling away from you until it collides with a surface. When the ball collides, then it bounces back. That's what he said. You throw a ball and the ball goes until it hits a particular surface. When it hits the surface, the ball bounces. That's exactly what happened in the waves. The wave is not ball, but behaves like ball. So when the wave travels from the source, like he said, propagated wave. Now, incidence, we will not use the word collide. If it were to be ball, we say collide and bounce back. But the technical term we use for wave, we will say the wave travels from the source. Incidence, not collide now. When the wave incidents on a given surface, the surface will now change the direction of the waves. The direction of the wave will now be changed after incidence on the surface. change in direction of the wave now is now called reflection. So in the same medium, when the direction of wave changes after incident on the surface, then you say such wave have been reflected. The wave collide with the surface, that is incident on the surface, and changes its direction. Change the direction of the wave in the same medium is referred to as reflection. And change the direction will only occur when the wave encounter a given surface. Change in direction will occur when the wave incident on the surface. So it means surface brings about change in direction of wave. Change in direction of wave is referred to as reflection, especially when it is in the same medium. The wave travels in air and incident on a surface and still travel in the same air. That means change in direction of wave in the same medium is called reflection. So when you say bounce, it's a term used for the ball. When I drop a ball now, the ball bounce. We use bounce for the ball, we use it for bouncing baby. You understand that? But you cannot say bouncing wave. It's not a technical term we use. Instead of using the word bounce, that's when we say reflect. To bounce is to reflect. The wave reflects, the wave does not bounce. Am I communicating? But it's similar. The wave will not reflect until it encounters a surface. And will not say it collide with the surface, but we say it's incident on the surface. And direction of wave will now be changed. The direction it was going before, I am a wave. The shear is here. I am a wave now, and I'm going. By the time I collide with the wall, I can't go again. I have to look for where I can change my direction to. I can go like I know I cannot continue going because of the ball or the wall. I have to find some other way by which I will go in the same class. Then I have been reflected if I'm a wave. But if I'm a ball now, I mean bounced back now. It depends on what you are. If you are a wave, you are going, you encounter with surface, then your direction changes in the same medium. That's what we call reflect. Change direction of wave in the same medium. After incident on surface is called reflection. I hope that is clear to you. Not a bit. Hello, girl. Is it a bit? I'm going to ask you a question next class, or rather, everybody will respond to. Now, there are two types of reflection. We have regular reflection and we have scattered reflection. We have regular and scatter. Scatter has other name. You have scatter reflection, or we call diffuse reflection, or we call it irregular reflection. Those three names are meant for one type of reflection. And that type of reflection occurs when the wave incident on rough surface. When the surface the wave collides with is rough, then the irregular reflection will occur. The irregular reflection is also known as what? Scatter reflection or diffuse reflection. It is the nature of the surface that determines what type of reflection that will occur from you. If you are smooth surface, then you can only produce regular reflection. Then if your surface is rough, your body that can only produce scattered reflection. But whether scattered or regular reflection is reflection, it occurs after the incident on the surface, after the encounter, the wave encounter the obstacle on its way. It has to change its direction. Change direction is what we call reflection. And we have law of reflection. We all know that. Can somebody remind me of law of reflection of wave? What are the laws?
The incident ray equals the reflected ray at the normal, where all place lies.
Okay.
Where place lies, where
all right.
all rays lies on the same.
Let's hear from the second person.
The law of reflection states that the angle of incidence is equal to the angle of incidence equal to the angle of reflection when it stands on the same surface.
Yes.
Most law of reflection state that the incident ray, the reflected ray, and the normal at the point of incidence all lie at the same point.
Okay, please clap for them. At least I encourage everyone to speak out his or her mind. That's why we call it classroom. I told you at the beginning of class that nobody is Mr. Know-all. I can make mistake. Speak out, then we correct one another. That is what we do in the classroom. Yes, I appreciated those that talk, but none of them put it the way it's supposed to be, and it's still okay. The first law is given by him. Let's have it down. Law of reflection. You can say law of reflection of wave or law of reflection of rays of light. Just say law of reflection of wave. There are two laws. One, the first law states that incident ray, reflected ray, the law of reflection, one, states that incident ray, reflected ray, and normal at the point of incidence all lie in the same plane. All lies in the same plane. Number two, the second law states that angle of incidence must be equal to angle of reflection. Or we put it as incident angle is equal to angle of reflection. So that is the laws of reflection. So when we get to light wave, we talk more about reflection of light. Now the next one, the second one, because of our time is even gone. It's already past 5. So refraction, I will stop at refraction. The messenger is coming already. It occurs when wave travel from one medium to another medium and change its direction. It is the change in direction of wave when the wave travels from one medium to another medium. Refraction is the change in direction of wave when the wave travels from one medium to another medium of different optical density. That's the condition. Of different optical density. If they have the same density, there will be no refraction. No. They must have different optical density before refraction occurs. Then you may want to ask, the first one is change the direction. This one too is change the direction. Mind you, the first one is in the same medium. But for refraction, it has to travel from one medium to another medium. Change in direction or bending away from the direction is called refraction. We'll continue from there next class.